Welcome to our fifth lesson on integration. In the previous lesson, we learned about indefinite integrals, and we saw that these are integrals in which the limits of integration have not been specified or are not provided. In this lesson, we'll be learning about area under a curve, and we'll be seeing how we can be able to use definite integrals to be able to determine the exact area under a given curve. In the topic area approximation, the area of the curve y is equals to half x squared plus 5 between the limits x is equals to 1 and x is equals to 5 when estimated using the trapezium rule is 41 square units. Remember, the area of 41 square units is just but an approximation, and therefore we may need to find a way of determining the exact area bound by the curve y is equals to half x squared plus 5, and for the provided limits x is equals to 1 and x is equals to 5. That method that you can be able to use to determine the exact area is integration. Integrating the curve y is equals to half x squared plus 5 for the provided limits, which are x is equals to 1 and x is equals to 5. If we were to find the area bound by the curve y is equals to half x squared plus 5 for the limits of x is equals to 1 and x is equals to 5, then it will be given by the integral from 1 to 5 over half x squared plus 5, and that will result to 1 over 6x cubed plus 5x plus the arbitrary constant c. And then we evaluate this particular integral for the limits x is equals to 1 and x is equals to 5, where 5 is the upper limit and 1 is the lower limit. So evaluating for the upper limit, we will get 5 cubed over 6 plus 5 multiplied by 5 plus the arbitrary constant c, and then we subtract the evaluation for the lower limit, which will give us 1 cubed over 6 plus 5 multiplied by 1 plus the arbitrary constant c, and that will result to 40 and 2/3 square units. The answer 40 and 2/3 square units is an exact area bounded by the curve y is equals to half x squared plus 5, and for the limits of x is equals to 1 and x is equals to 5. In general, to determine the exact area under the curve, say y is equals to x squared, within the limits, say x is equals to a and x is equals to b, involves integrating the equation of the curve and evaluating the resulting integral at the limits of x is equals to a and x is equals to b. And this can be represented by the equation of a is equals to the integral from x is equals to a to x is equals to b y dx, where y is the equation of the curve. Example number 1. Find the exact area enclosed by the curve y is equals to x squared, the x-axis, and the lines x is equals to 2 and x is equals to 4. Now we note that in this question, the limits within which we are required to determine the area bound by the curve y is equals to x squared have been provided, and x is equals to 2 and x is equals to 4. Also, the diagram shown over here indicates that particular region that we wish to find its area. And therefore, for us to be able to determine that particular area, as already noted, we integrate the curve y is equals to x squared and then evaluate the resulting integral for the limits of x is equals to 2 and x is equals to 4. Therefore, that particular area will be equal to the integral, which we get as a third x cubed plus the arbitrary constant c. And then evaluating for the upper limit, you're going to have a third into 4 cubed plus the arbitrary constant c. And then we also evaluate the integral for the lower limit, which will give us a third into 2 cubed plus the arbitrary constant c. Getting the difference between the two, we are going to have 16 and 2/3 square units, which becomes the area bounded by the curve y is equals to x squared, and the limits of x is equals to 2 and x is equals to 4. Example number 2. Find the area of the region bounded by the curve y is equals to x cubed minus 3x squared plus 2x, the x-axis, and x is equals to 1 and x is equals to 2. Now again, we also take note of that the limits of within which you need to find the area has been provided, and that is x is equals to 1 and x is equals to 2, and also within the x-axis. So also, as we noted from the previous example, for us to be able to determine the area under that particular curve for the provided limits, we integrate the equation of the curve for the limits of x is equals to 1 and x is equals to 2. And that will be able to give us x to power 4 over 4 minus 3x cubed over 3 plus 2x squared over 2 plus the arbitrarily constant c. So again, we will evaluate this integral for the upper limit, which will give us 2 to the power 4 over 4 minus 2 cubed plus 2 to the power 4. And then we shall subtract the integral evaluated for the lower limit, which is 1 to the power 4 over 4 minus 1 cubed plus 1 to the power 4. And this results to 4 minus 8 plus 4 for the upper limit. And for the lower limit, you are getting a quarter minus 1 plus 1. And adding up the two results, we are going to have 0 minus a quarter and giving us a result of minus a quarter. Now you'll notice that in this particular working, we found a negative result. And from understanding, we know that the area of any given region can never be equal to a negative. So what does this particular negative really mean in this particular question? So the negative in this particular question basically tells us that the region whose area we are finding is below the x-axis, and this is illustrated on this diagram that is shown over here. So as you can see, the curve for y is equals to x cubed minus 3x squared plus 2x is drawn as shown on the diagram. And then we have the limit of x is equals to 1 and x is equals to 2. And then that shaded region is the region that we were required to find its area. So you'll notice that it is below the x-axis, and hence us getting that particular negative area. So therefore, we shall ignore the negative and give the area of the region bound by the curve y is equals to x cubed minus 3x squared plus 2x, and within the limits of x is equals to 1 and x is equals to 2 are simply a quarter square unit. So every time you're working out the area bound by the curve and for the provided limits and you're finding a negative result, that just tells you that the area that you're finding is the one that is below the x-axis. Example number 3. Find the area enclosed by the curve y is equals to x squared minus 10x plus 9, the x-axis and the lines x is equals to 4 and x is equals to 10. Now again, we note that the limits within which you need to find the area is indicated as x equals to 4 and x is equals to 10. And the region whose area we are required to find is indicated on this particular diagram on the left side of your screen. And you'll notice that there are two regions. We have one below the x-axis and one above the x-axis. So to find the area bounded by the curve y is equals to x squared minus 10x plus 9, and for the limit of x is equals to 4 and x is equals to 10, we will need to find the area below the x-axis and we add it to the one above the x-axis. So the equation for finding this particular area is given by the integral from 4 to 9 x squared minus 10x plus 9 dx, and then added to the integral from 9 to 10 x squared minus 10x plus 9 dx. Evaluating the areas for the two regions, we are going to get the area is equals to the integral from 4 to 9 x squared minus 10x plus 9 dx, and then added to the integral from 9 to 10 x squared minus 10x plus 9 dx. And so for the first one, we are going to have x cubed over 3 minus 5x squared plus 9x, and then we shall evaluate for x is equals to 4 and x is equals to 9. And then for the second one, we're getting the same integral of x is equals to x cubed over 3 minus 5x squared plus 9x, and then we shall evaluate for x is equals to 9 and x is equals to 10. And so for the first one, you're going to get for the upper limit, you're getting 243 minus 405 plus 81, and then we shall subtract the integral evaluated for the lower limit, which gives us 64 over 3 minus 80 plus 36, and that we'll be able to simplify to negative 58 and a third. And then for the second one, we're going to have for the upper limit 1000 over 3 minus 500 plus 90, and then we shall subtract for the lower limit, which gives us 243 minus 405 plus 81, and that will be able to simplify to 4 1/3. Now we shall ignore the negative for the first region because as we noted, it is the region that is below the x-axis, and so we are going to have 58 1/3, and then we shall add the second region, which is 4 1/3, and that will give us a total area of 62 2/3 square units. Time to put to practice what you've learned in this lesson. Pause the video and try these questions. That's all for now. See you in our next lesson.